Professor, I think you're muted.
Yeah, thank you. It looks like my internet here went down, right? But we are back now. Okay, so let's go back to my screen here. Was did I take too long to get back here, or it was almost a small amount of time? How long it took? How long I was offline here?
Not too long, maybe like
Not
five
long?
seconds.
Huh? Less than 1 minute?
Yeah, less than 1 minute.
Ah, okay, good. Okay. I do not know why I'm having this problem. I never had this problem. It looks like the problem is the internet. It looks like it's the new service that I purchased that's giving me this hard time, unfortunately. So let's see if I can fix that. Okay. So here you go. Now, example number 3, right? I was doing example 1, 2, and 3. Example 1, it is I measure the diameter of a sphere with a ruler, right? And I know what's the number of significant figures that we have with the ruler. And then from the number of significant figures of the diameter of the ruler, I can find out, I know how many significant figures the volume is going to have. In the second case, I have a rectangle that's being measured. One side is being measured with a ruler, the other side is being measured with a vernier caliper, right? So in both cases, the number of significant figures of each side, it has 3 significant figures. Consequently, the area must have 3 significant figures as well. In the third case, both sides of the same rectangle are now measured with the ruler only. Because of that, one measurement is going to have 3 significant figures, the other is going to have 2 significant figures only. Consequently, when we take the area of this rectangle, we must display the result of the area with 2 significant figures only. Okay, only. Okay, so that we covered before. And now we have to cover something else. Which is the rule for significant figures for addition and subtraction. Okay, what is the rule? What is the significant sig figs rule for addition and subtraction? Okay, we didn't have to cover that in the first lab, but we have to cover that in the second lab, because in the second lab, you are supposed to take to some several measurements that were made. And I'm going to show what that is, right? For the case, if for multiplication, right? Multiplication, you must worry about the number of sig figs, okay? The number, here you go. The number of sig figs, and I'm going to emphasize here. Number of sig figs, comma, for addition and subtraction. And that number of sig figs, and I'm going to copy it. For addition and subtraction, you have to worry about the number of decimal places of your measurement, okay? See the difference here? One, you consider the number of significant figures. The other, you have to consider the number of decimal places, okay? In both cases, you take the least number. Okay, here's the least number of significant figures. Here's the least number of decimal places. Here you go. I'm going to write it down here. Least number of sig figs. In the other one, is the least number of decimal places. That's the rule for decimal places of your measurement slash result. Okay? That's the rule for addition and subtraction. Example. Let's come up with an example. Example. And I'm going to use exactly the same example that I had here for the rectangle. Okay? I'm going to repeat that, but with a different result. Here you go. Example number 4 and 5, right? This one will be gonna example number 5. This one here is gonna be example number 4. Let a rectangle, okay? Let a rectangle with sides, right? S1 and S2 equal to whatever. The first measurement rectangle with, let's see, with 4 sides. 4 sides, S1. Let's see, I'm gonna make a little bit different than I did before. S1, S2, S3, S4, okay? Like that. S1 with 4 sides, S1, S2, S3, and S4. Okay? S1 is going to be equal to S3. Okay? S2 is going to be equal to S4 because it's a rectangle, right? The first measurement was measure with a ruler. The second one was measure with a vertical. Yeah, the first two sets of measurements was made with a ruler. The second two sets of measurements was made with a vernier caliper. Find the number of significant figures, not of the area, but of the perimeter of this rectangle, okay? Of this rectangle. So because it's a perimeter now, perimeter I'm gonna call P. Because it's a perimeter now, then we have to sum each measurement, right? S3 plus S4, right? And now I'm going to do that, the summation, in a spreadsheet so you can visualize that better, okay? You can visualize that better. Here you go. Let's see. Let's use this one here. That's S1, that's S2, that's S3, that's S4. No, you know what? Let's put in the horizontal. It's better if we put that in the horizontal. Font, subscript, okay, here goes. S1, hopefully S2, S3, S4. Yeah, got it? Okay, this one, let me erase that. And let's not forget, all those measurements are in meters. Okay, meters. No, meters, meters, and meters. S3, S4. This is a topic of, this we are going to use in lab 2, okay? And I'm gonna write that down here, the values. Here we go. S1. You know what? let's do in the vertical. Now that I'm recognizing that's better that you do in the vertical, not in the horizontal, okay? Oh, now I'm recognizing that it's better we do in the vertical so you can visualize the numbers better. Okay, here you go. S1 is 0.122. Let me unbold it. S3 is also 0.122, right? And S2 and S4 is 0.0934, okay? And also 0.0934. Now, what I'm going to do here, I'm going to left justify the same so you can visualize those numbers in a better way. Yeah, left justify here. Do you see that? That's S1, that's S2, that's S3, that's S4. You do know that the perimeter, right, which is also going to be given in meters, is going to be the summation of all those measurements. Here you go. And I'm going to left justify it so I can see my decimal places properly. Okay? S1 and S3 has 3 decimal places. S2 and S4 has 4 decimal places. And remember, your final result must be one such that you keep the least number of decimal places. Okay, so instead of writing perimeter equal to 0.4308, you are going to write down perimeter as being 0.431. Okay, you have to round up whenever the last digit is above 5. It's 5 or above. It goes number. So instead of instead of 4 decimal places, we are going to have 3 decimal places. That's how you display this result. Okay? That's the rule for summation and subtraction. And I'm gonna keep like that. You go like that. You go. And now I can go ahead, copy this thing, and paste there in my document. Did you get the idea? So the same rule applies for subtraction. And you're going to use this rule this one here? Yeah, this one right here. Let's see, I can get, here you go. Oh, why you didn't do that? Yeah, so I have got to do that manually. Oops. And like I said, I left justify this number because I want you to keep track of the decimal places, right? Where they lie, where the decimal places lie. Okay? First, you let the rectangle side, blah, 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 find the number of significant figures. And what else here? If for, yeah. And now, rule for summation. The rule okay. Okay, for summation and subtraction, I don't think I'm gonna put it here for summation and subtraction. You keep, you write, not you write your result with the using the least number of decimal places as displayed in your original measurement. Okay, measurement. So that's the importance. That's the difference between the rule for significant figures for summations to be tracked and the rule for multiplication and division. And you are going to use this rule in your spreadsheet, right? Let's go back to our spreadsheet here. Let's go back to our spreadsheet. Spring labs, right in here. Raw data. Lab number 2. When I use this one right in here, let's take a look at this guy. View. I want 200%. 200% is too much. Let's try 100%. Yeah, better, right? So where do you use the rule for the rule of summation for significant digits here? You use right in here for those measurements. The measurement of the position Y, okay, was taken with the tape measurement that has a resolution of 1 millimeter, right? So I'm going to display it with the proper number of significant digits, numeric, 3 decimal places because the resolution is in millimeters. I'm going to left justify these measurements because I want to keep track of my number of significant figures. So what do we have to do here? We have to take the average of all those 5 values for Y. Y is the position of the photo gate. Remember that? Y is the position of the photo gate. Okay, so first, in order to take the average, first we sum all those measurements. Here you go, and I'm going to display them with the proper number of significant digits. And we keep the least number of decimals, right? All of them, all those measurements have 3, the same number of decimal places. They have 3 decimal places. Consequently, the summation of those measurements are going to have 3 decimal places as well, with one very important detail. One very important detail. Because you are summing the different measurement, which is the position of the photo gate, you sometimes, not all, it doesn't happen all the time, sometimes you end up with 4 significant digits when you had only 3 initially for each one. Do you see that? You're summing everything, and by the fact that they are summing those measurements, you end up with a larger number of significant digits. Okay? And then when you take now the average of this value, you gotta divide it by 4, right? First, you have to use the rule of significant figure for summation. And then last, you have to use the rule of significant digits for division. The average is going to be the division of the sum of those 4 measurements. And what's going to happen? You are going to end up increasing the number of significant digits. What was 3 significant digits here, 3 significant digits here, and 3, and so on, now is going to be 4 here because you gained a significant digit when you sum your previous 5 measurements. Isn't that nice? Okay, so by repeating an experiment several times, you may end up increasing your number of significant digits. That's a nice example for you to keep in mind, okay? And this average value of y is going to be used in this equation right here, okay? X minus y is going to be the absolute value of them. And in this case, you will have to use the rule for subtraction. Here you use the rule for addition, right? Here you're going to use the rule for subtraction. Addition, subtraction, addition and subtraction. Those are what you have here. Those are actual measurements. What you have here, those are actual measurements, right? And what you have here is going to be a result. I'm going to put under a different color. Here you go. What about this color? No, I don't want this color. Let's put the lower green. Green is better, right? Here is going to be a measurement as well with your photo gate measurement. Here you go. This one is going to be a result. This one is going to be a result. This one is going to be a result. Here you go. See the difference? Right? This result is obtained by adding those 5 measurements. This result is obtained by dividing this previous result by 5, right? This other result here is obtained by subtracting this result from those measurements. This other result is obtained by dividing this measurement by this other measurement, right? And this other result is obtained by squaring the value of this previous result, okay? So that's what I want to cover with you. And now you have enough information to finish this lab number 2. Okay, so now you have enough information to finish the report for lab 2. Right now is what? 10:28, right? I want to take a quick attendance here. Every now and then I'm going to do that. I'm not going to do that all the time, but every now and then I will do it. So just to keep on track of who's coming, who's not coming. Sometimes I shouldn't drop, right? I shouldn't drop from the course, but forget to formally drop from the roster. And then I'm required to drop those students myself, okay? So that's why I'm taking the attendance right now. Here you go. Insert code, here you go. Arturo Lagunas. I don't see Arturo here. Format cell number. Here you go. Next is Jania Tapia. I don't see Jania Tapia here. Okay, next is Eric Alcala.
Here.
Thank you, Edith. Next is Edith
Here.
Alexandrian. Okay, Edith here, right? Thank you, Edith. Jawaida Ali. Let's see if Jawaida is here. I don't see Jawaida. Looks like Arturo just joined us, right? Is that Arturo that just joined us? Arturo Lagunas?
Yes.
Okay, thank you. Arwa? Arwa Paris? I don't see Arwa here. Catherine Perez? I don't see Catherine. Next is Ben Bandoy. Looks like Ben is here, right, Ben? Okay, let's see. Send it. Yeah, okay, thank you, Ben. Melissa Bedoya. Let's see if Melissa is here. I don't see Melissa in my Zoom roster. Isabel Medina. Isabel. I don't see Isabel. Oops, wait a minute. No. Delisha, right? I skipped Delisha. Are you there, Delisha?
Yeah, I'm here.
Thank you. D, right? Queen Castaneda.
Here.
Thank you, Queen. Emily Serna.
Here.
Thank you, Emily. Gabriela Edwards.
Here.
Thank you, Gabriela. Carlo Gallardo.
Here.
Thank you, Carlo. Angelica Franco. I don't see Angelica here. Princess.
Here.
Thank you, Princess. And just arrived, right? Can you hear me, Arwa? Arwa Paris. Okay, I'll put attendance here for you, Arwa. I'm not hearing you, but I see that you are hearing my roster. Brandon Guerrero.
Here.
Next is Janie Maldonado. I don't see Janie. Next is Kimberly Morales. I see Kimberly here.
Here.
Okay, thank you, Kimberly. Montserrat Morales. Thank you, Montserrat. Nicholas Rivera. Nicholas is not here, right? Next one, Jason.
Here.
Okay, Jason Sevillon. Armand Taff. I don't see Armand. Next is Juan Torres Arellano. Okay, Juan is here. Thank you, Juan. Cecilia Chavez.
Good morning, I'm here.
Morning, thank you. Jacob Contreras. Jacob's here too. Evelyn Ayala. Evelyn Ayala. I don't see Evelyn. Okay. Isabella Cisnero. I don't see Isabella either. Trin. Trin is here. Thank you. Elizabeth Saldana. Elizabeth's here. And let's see how many students we have total. 20 students, 21 in my roster. So this number looks good. And let's have our break. Break. That's 10:35 a.m. to 10:50 a.m. Okay. So I see you in 15 minutes. And then in 15 minutes, we will start lab number 3, okay? Thank you. Okay, I'm back here. So let's talk about lab number 3. Let's start from scratch here. Home, insert, page break, lab number 3. Lab number 3 is closely force table. That's the name of this lab. It's this is a lab experiment that we do to show you folks that the concept of vectors, okay, the concept of vectors. So we have a specific experiment that demonstrates in practice how vectors sum in the two-dimensional space. Okay, let's write it down. This experiment is to demonstrate in real life practice how vectors sum in the 2D space. Okay, and it works the theory and we compare the theory with the experimental results. Okay, that's what we do here. And okay, and the way we do this experiment is the following. You know, given two masses pulling two different strings at a given angle, find the mass and the angle required. Find the mass, find what would be the resulting, what would be, find what, here you go, what would be the mass and angle required to cancel the forces provided by the first two masses, right? By the first two masses. So that's what we do in this experiment. And I'm gonna get now my slides. Something here is wrong. Okay, here you go. Nice. Okay, so here you go. We have a table. It's a metal table that we call a force table. I'm gonna show you a video too, so you can have a better idea how this whole thing works. We have a system of pulley and clamps that are clamped at specific positions in this table. And by the way, this table is graduated in degrees, okay? That's the clamp part of the device, and that's the pulley part of the device. Okay, first quadrant, second quadrant, third quadrant, fourth quadrant of my table, of my circular table. And then what do? We pass a string, we attach a string to a ring. Okay, we attach a string to a ring. And this ring is placed at the center of the table. Okay, and then we can start documenting all the equipment, right? So let's talk about the equipment here. I'm gonna write that down there. Here you go. Equipment. Circular metal table with a protractor drawn on its top. Okay. So it's graduated. Resolution of the protractor is 0.5 degrees. Okay. Someone's 0.5 degrees. I didn't draw the degrees here because it would be too much work. Okay. So what else? Let's start with the here you go. Pulley clamp, 3 pulley clamps combination. Combination of 3. Let's see. No, wait a minute. 3 pulley clamps. 3 pulley clamp combination. Okay. 3 pulley clamp combination. And that's what you see right here, right in this illustration. That's the clamp, that's the pulley, Next, we have strings and 3 strings and a ring. Here you go. 3 strings and a ring. The 3 strings attached to a ring. 3 strings attached to a ring. What else? Let's see. A mass holder. Mass holder. That's the mass holder right in here. Seen from the top. 3 mass holders. That can be loaded with masses. With different masses. Can be loaded with different masses. Let's see how they look like. Let's see before we keep on going. So you don't get lost. For stable experiment. Isn't that nice? Oh, here you go. The artificial intelligence just show us that what the device looks like. Okay, so let's see. Okay, I think that's good enough, right? So here's the table, the circular table, metal table. You can see it's graduated. The resolution of this one is ½ degree. If you come close enough, you're going to see is a ½ degree resolution. Okay, 1, 2, 3, 4. Yeah, ½ degree. Here's the clamp. The black device here is the clamp. Let's see if I can download it. Can I download it? And let's see. Okay, I cannot download it. Let me get a picture from elsewhere so we can download it. This one maybe. I don't want this this type of. I want a static figure so I can zoom in better on that figure. Let's see this one here. Let's see. Yeah, look, can I zoom in? Yeah, I can zoom in, right? Zoom in, zoom out. This table itself doesn't has only 1 degree of resolution, but the one that we use there at LA Harbor has another division, has another ½ degree resolution. Okay, so here's the clamp that I mentioned to you. okay, to keep the pulley at a given position. So it's the clamp pulley combination. Clamp pulley combination. The way we do this experiment is only 3 clamp and pulley combination. Here they display 4 of them, right? But I found out that it was better to do the experiment with only 3 of those. And we have this device that you see here is the mass holder. The mass holder with the masses loaded in there. Okay, those masses that you see here, here is one mass, here's another mass, here's another mass, here's another mass, right? From larger to smaller, those are called the slotted masses. We have something like that. It's not exactly like that at LA Harbor, but it's quite similar. Okay, here you go. That mass holder that we hang from the end of the string. Here's the ring and the string. The string passes through the pulley, and we hang a mass at the end of each of those strings. Okay. Now let's continue with our stuff there before we get behind. 3 mass holders that can be loaded with different slotted masses, right? Slotted masses with different slotted masses. Several slotted masses, and you have a bunch of those. Every college has a bunch of those slotted masses. Do you see how the slotted masses look like? So you can picture how this experiment is performed. Okay, it has a notch. See those slotted masses has a slot here. So you can slide the slotted masses on the mass holder. Okay. Several slotted masses. Let's see. The scale that we used before in the experiment of the spheres. The scale with a mass resolution of 100 of a gram. Okay. Circular metal table. I'm going to do the following. I'm going to put it as though it is a different device, okay? A protractor drawn on the top of the metal table, of the metal table, with a resolution of ½ degree. So you're going to need that to display your spreadsheet with the proper number of significant figures, okay? 3 mass holders, assorted is, I'll say assorted slotted masses. So that is the whole setup that we need. That's the equipment, the whole equipment that we need. Okay? That's the whole equipment that we need. So what do we do? First, we'll clamp pulley number 1 at 0 degree angle. That's what I call theta 1 in my spreadsheet. And by the way, let me upload. I forgot to upload the spreadsheet, right? Let me upload the spreadsheet to you right now so you can follow with the spreadsheet. Now that we're talking about the spreadsheets. And let's first make sure the spreadsheets are clean and doesn't have anything else. Okay, so view. Let's zoom out. Yeah, doesn't look like we have anything here. Okay, this one is good. Zoom out. 50. This one seems to be good as well. View. 50%. Okay, yeah, this one seems to be good. One more here. Boom, 50%. Yep. One more view. 50%. Clean, clean. Yep. View. One more view. Okay, so seems to be fine here. We have a total of 13 groups, right? So here we go.
Wait. Now.
Oops. Yeah. Okay, this one here. Okay, now I'm gonna upload these spreadsheets to your group folder. Google Drive, 2025, fall folder, group number 1. Why am I having a problem? Okay, here you go. Group number 1, your spreadsheet's in there. Group number 2, your spreadsheet's in there. Group number 3, your spreadsheet's in there. Hey, what's going on here? Yeah, okay, good. Group number 4, your spreadsheet's in there. Group number 5. Group number 6. Group number 7. Group number 8. Group number 9. Group number 10. See here. Roster. Oh, it's a total of 14 groups. Okay. Group number 10. Group number 11. Group number 12. Group number 14, 14 to 13. And one more group here. Group number 14. Okay, so make sure you download the spreadsheets to your hard drive. Download the spreadsheet to your hard drive. Okay. And again, how do we do the experiment? First, we clamp pulley number 1 at 0 degrees. Okay. Another clamp pulley number 2 at the right 0 degree angle at the 90-degree angle. Okay. Clamp pulley number 3 at the opposite quadrant with respect to the other pulleys, right? So here you go. Let's say this one is 0 degree. Let's see, this one is 0 degrees. This one is 90. Let's say this one is, let's see, which one is 0? Okay, this one is 0 degrees. Let's say this one is 90. And then you clamp the third pulley anywhere along the third the opposite quadrant, right? Pulley number 1 and number 2 subintend this quadrant. So clamp pulley number 3 anywhere along the opposite quadrant. Place the ring at the center of the table. And that what, let me, here go, ring right in here. Ring at the center of the table. And I'm going to fill with nothing. Here you go. What you have here at the center of the table is a pin to ensure that the pulley doesn't slide off, to ensure that the circle, the ring, doesn't slide off from the table completely. Place the ring at the center of the table. Pass string number 1 through pulley number 1 and attach it. Pass the string number. The strings are already attached to the ring, okay? String number 2 through pulley number 2. Pass string number 3 through pulley number 3. And that's what we have right in here. There you go. Let's say that's 1, 2, and 3, right? Pulley 1, 2, and 3. Pulley slash string. Pulley clamp string. 1, 2, and 3. Okay. So the problem, right? Given the problem that we are going to solve is the following. Given theta 1 and theta 2, given theta 1, comma, theta 2, mass M1 and masses M1 given theta 1, theta 2, and masses let's see. The way we do is like that, constant. Constant, what are constants? Is the angle theta 1, the angle theta 2, and mass m1, okay? Those are constants. Mass m1 is the one that is loaded into the mass holder, number 1. Constant, theta 1, theta 2, and m1. What is going to vary given, what are given, right? What's given? We have those constants that are given. And we also have a variable parameter that's also given, mass m2. But that's going to be variable. We're going to change these masses to change the pulley in the string, to change the tension in the string, okay? Note that the masses m1 and m2 are applying a tension in their respective strings, right? Right in here, you go. Here are the masses loaded, m1, right? m2 here, m1 and the angle theta 1. Here you go, m2 and the angle theta 2. What's going to be variable is going to be this mass m2. We're going to vary this mass m2, and we're going to find the corresponding mass m3 and the angle. That's what we're going to do in this experiment. Okay? For each combination given, given constant mass, find m3 and theta 3 that will equilibrate the system. And by equilibrate the system, that will keep the ring centered on the top of the table. Okay? That was the problem that we are going to solve, that the experimental problem that we are going to solve. And the way we do that, in order to do that, we do the following. In order to do that, first, we load M1 and M2, that's a very important step here. Then we pull string 3 to find the proper angle where we are capable of equilibrating the system. We pull with our hand, okay? We pull string with our own hand, to find the proper angle where we're capable of equilibrating the whole system. The whole system, like that. Okay? After finding this angle, proper angle, theta 3, where we are capable of equilibrating the whole system. After finding theta 3, we load the mass hanger little by little until we go. After finding theta 3, we release, right, the string and load it. And load the mass hanger, the third mass hanger, little by little, until the system is in equilibrium. Like that. To do that, we first load M1 and M2. M1 and M2. Then we pull a string with our own hand to find the proper angle θ3, where we are capable of to equilibrate the whole system. After finding θ3, we release the string and load the third mass hanger little by little until the system is back in equilibrium. So first, we use the force in our hand, right, to equilibrate the system. But just by applying a force with our hand, we do not know how much force that is, okay? We can have a qualitative idea that we are equilibrating the system, but we do not know in a quantitative fashion what is the force that the hand is actually applying to the string. So in order to find this exact force, we have to load the system little by little with the mass, with the slotted masses. We release the string and load the third mass hanger little by little with the slotted masses until the system is back in equilibrium. That's how we do. Let's see how it looks like. Here you go. Mass 1, mass 2, mass 3 is going to be mass 3 and θ3 is going to be found, right? When the whole system is in equilibrium, we are going to have this situation here. The ring is going to be centered, right? That's going to be my angle θ3. Here is the resulting force being applied. Mass M1 is applying a tension F1. Mass M2 is applying a tension F2. Those two forces summed up result in this resultant force. And we want to equilibrate this resultant force by adding slotted masses to the mass hanger number 3. And that's what we get here in, let's see, I'm gonna get my spreadsheet to display that for you. Here you go. Here's one of the spreadsheets. Okay. Don't forget to write down your group number and the student names. Write student number 1 and student number 2, the date. Please do that. Okay. I need you to have your names here and your group number 2. When I correct it, I'm always making references to those cells. Here's the mass 1. Here's the mass 1. We measure the whole set with the mass hanger and the slotted mass using the scale. You know that the scale has 5 decimal places in kilograms. Okay. And here's the angle. Mass 1 is an angle of 0 degrees. Note that mass number 1 that I used in this spreadsheet is 300 grams. Okay? All those measurements, 1, 2, 3, 4, 5, 6, is 300 grams. But I am changing mass number 2. The first mass number 2 is 200 grams. The next one is 250. The other one is 300, 350, 400, and 450. That's for this specific spreadsheet. It should be different for other spreadsheets, right? And the angle is 90 degrees. Okay? What you see writing here are my measurements. Let me put in yellow color for the measurement. What you see here is also going to be a measurement. Don't forget to put the correct significant figures for the angle, right? Resolution is ½ degree. Here we are going to lower, you're going to find the lowest mass required to equilibrate the system. And here we're going to find the highest mass that still keep the system in equilibrium. And those two are also measurements because we're measuring the masses. Lower value of the third mass, upper value of the third mass. And here is the angle, right, that we found when we applied our own hand in the system. Okay? What's next? Well, now it has to do with the theory. Okay, going back to the drawing the drawing board. What you have right in here is just the case of the Pythagorean triangle, because those two forces are making an angle of 90 degrees, right? So the resulting force that you see in this slide is going to be, I'm gonna put here, according to the Pythagorean theorem, the resulting force squared, right, is going to be equal to F1 squared plus F2 squared, right? But let's not forget that force 1 squared is equal to what? Is equal to the tension in the string, which in the first string, which is going to be M1G. This M1G is squared. And we get the same for the force number 2. With just a different index, right? Okay, M2. Like that. And by the way, this resulting force is going to be what? It's going to be my third mass square, right? The one's going to be hanging there in the opposite quadrant. That's going to be M3G square. We don't need that. So that's the relationship that we have. We can make this relationship simpler, even simpler, because we have G repeating on both sides of the equation. Because we have G repeating on both sides of the equation, we can cancel G here, cancel G here, and cancel G here, right? I'm going to raise to the square here so it looks nicer than that. Just change the subscript M2 and change the subscript here, M3. That's the relationship that we have between the masses. That's the theory, right? And we want to verify this theory experimentally. So what do we do? What do we do? Okay, in this experiment, we keep M1 constant and vary M2. Vary M2, right? And find the resulting M3. So the equation that we have, let's see, I'm going to put it on this M3 on the left side. What do you have here? Making M3 squared equal to my dependent variable y, and M2 squared equal to my independent variable x, okay, we have the following equation. We have the following equation. What was m3 squared on the left side becomes y. Don't forget, m2 is a variable. What, this one's going to be y. This is going to be x. And the coefficient in front of x is going to be the number 1, right? Here is the slope. Here's the intercept. The slope is equal to 1. The slope equal to 1. Intercept and intercept equal to m1 squared. So that's what you need to do. You gotta plot m3 squared, m3 squared along the y-axis, and m2 squared along the x-axis. Going back to our spreadsheet, m2 squared is going to be our result. m3 average, which is going to be the average of those two values, is going to be our result as well. Then we are going to have m3 square average, m3 average square. Okay, another result. m2 divided by m1 is going to be another result as well. We need that, and there's a reason why we need that. I'm going to show you very soon. And the tangent of theta 3 is going to be our other result. Plot m2 square along the x-axis and m3 average square along the y-axis. You're also going to plot m2 divided by m1 in the x-axis and tangent theta 3 in the y-axis. Why do we do that? Well, we do that because there is another relation. So we're talking about two graphs here, right? There's another relation that you have to verify. And this other relation is m2 divided by m1 is equal to tangent of theta 3. Just go here, right? m2 divided by m1 is going to be this angle here, which, by the way, is going to be this angle here as well. That's what I'm calling theta 3. Okay? Can you do that? It is, let's see, it's time for another break, right? It is 11:36 right now. Any questions about that? It's just your regular Pythagorean theorem that you saw over and over again in math, right? Two plots, two graphs. Let's see. Plot M3. Plot two graphs. M3 average square along the y-axis, M2 square along the x-axis. Slope should be 1, intercept should be M1 square. Tangent of theta 3 along the y-axis, M2 over M1 along the x-axis. Slope should be 1 as well. Okay, what else do we have to do? Log the slopes and intercept on the last table. Obtain the percentage difference. Okay. Log all units, type all units, right? Let's put type. Type the slopes. Intercept on the last table and obtain the percentage differences. type all units, display the proper number of sig figs, fill up the regression equation R squared, find the CL. Okay, and that is 11:38 right now. $55, $53, right? Yeah, let's have our break now. I see you in 15 minutes. Okay, I'm back here. And now I want you to start plotting your graphs, right? Two different graphs is M3 average square along the y-axis, M2 square along the x-axis. Insert chart plot. And we see that we get a straight line, right? And we go ahead, add trend line, display equation chart. You do not get, here go the slope. The slope that I get here is not exactly 1, but it's very close to 1. It's 2% off only. And then you gotta put the labels with the units, right? On both axes. Let me just go one by one and see if you're having any problems there. The first thing that I want to know is if you download your spreadsheet. Arturo, is Arturo there? No, Arturo, looks like Arturo left. Here you go. Next, Jania is not here. Eric Alcala, did you manage to download the spreadsheet, Eric?
Yeah.
Okay. And then the next question is, have you plotted your graph?
I'm working on it.
Plot graph 1, right? Still 1, still working. Here you go, O and O. Next, Edith, did you manage to download your spreadsheet?
Yes, I downloaded it and I'm just starting to plot them.
Okay, so you're plotting graph number 1. Okay. Jawaria, is Jawaria there? Let's see. No, Jawaria is not here. Next, Catherine. I don't see Catherine here either. Oh, no, sorry. Arwa Paris.
Yes, I've downloaded the file.
Yeah, did you plot the first graph as well?
No.
Not yet? Okay, so you're still working on that. Thank you. Catherine is not here. Next is Ben Bendoy. Did you manage to download your graph, Ben? I can't hear you, Ben. Oh, let's see. Let's see. Looks like I have a, okay, good. Wow. Okay, this slope's a little bit far. Let's see what's going on with this slope, right? Ben is giving me, okay, he downloaded, plot the graph. Yes, you're group number 3. Let's see what's going on here. Slope 1. Slope 1 is almost 30% difference. Your slope, 7.71. More like 29% difference. Let's see if there's anything wrong with this value. Group number 3. That's group number 3. I'm going to plot the graph M3 average square, M2 square. Insert chart. Let's see here, add trend line, display R square. Yeah, that's right. Okay, so yeah, there's nothing. Okay, so whatever you got is the correct value. I suspect, just by looking at the graph, I suspect that those 2 points here at the end of the curve, I suspect that they are incorrect. They are not properly taken. Okay, that's my suspicion. And we can find that out if that's the case or not. Is let's see here. Okay, the 2 points at the end of the curve, Ben, should be the last 2 here in the table, okay? Let's exclude them from the plot and let's see if we get a better, yeah, in a way we get a better slope. It's not much better, it's 0.8085, it's not much better, okay? But most likely the problem was one of those 2 points here that, yeah, that's right. The last one and the one before the last one, that's what looks like. Looks like they are the outliers here that diverging from the actual result. But either way, the other points also, but that's okay. You don't need to do anything, okay? It's the data that you have in there. And if we were doing the actual experiment in class, I would ask you to repeat the experiment. Okay, so you can move on to the graph number 2. Next is Melissa, right? Melissa, is Melissa there? I don't see Melissa. Next is Delisha.
Yeah, I'm here. Still working on the chart.
On the chart, okay, good. So you're able to download the graph, the spreadsheet, right? No problem with that. Isabel is not here. Next, Queen. Are you there, Queen? I don't see it. Next, Emily Serna. I don't see Emily either. Next, Gabriela. Did you download your spreadsheet, Gabriela? Waiting for Gabriela to answer. It looks like she's away from her computer. Let me put just a star here under her name. And let's go for Carlo Gallardo. Did you download your spreadsheet, Carlo?
Yes, I was able to download it.
Okay, did you manage to plot the first graph?
Yeah, I plotted the first graph.
What's the slope that you got?
I got 0.9938.
Okay, so you have better data, right? So that was what it is. And don't forget the percentage difference, right? Percentage difference of 1, and then you gotta plot graph 2. Did you plot graph 2 as well?
No, what table do we use again to plot the second one?
Okay, well, what's the question?
Well, which chart do we use to plot the second?
Okay, this is here in the
graph?
notes, right? Let's take a look at the notes. Here you go. Plot 2 graphs. This one you already plotted. Now you gotta plot this one here. Tangent of theta 3 along the y-axis, m2 divided by m1 along the x-axis.
Okay. Thank you.
Okay, so the graph that you should plot in the table, let's see, not this one. is this one right in here, theta 3 and M2 divided by M1. If I plot it, chart, yeah, I get, I get kind of an outlier here. Looks like everything else falls in the right direction. And let's see what the equation do we get on the slope. Okay, I want to zoom it 100%. Yeah, it's too small for me. Let's go 150. Yeah, I'm getting 0.8382. It's 17% difference, 16% difference. Okay, for this specific data that I got. If we eliminate those two data points, let's see if we get a better slope. Sometimes we do this exercise just to look for to see what is wrong, right, with the data. And I'm going to eliminate the last two. And let's see what I get. Yeah, now I got only a 2% difference, right? Only a 2% difference between the actual result and the experimental one. If I add just one of the points, let's see, we can do that as well. Here you go. It looks like the problem was this number 5. Okay, I'm going to replot my graph with just that one that looked bad, just excluding one of the points. Just excluding one of the points. Yeah, 89, 11% difference, 10% difference. Okay, so it is that point that I exclude, and this one that's skewing the curve in the wrong direction. Okay, and again, if you were doing the actual experiment, I would ask my students to repeat those 2 points that don't look good. Okay, the 2 points I'm talking about are those 2 that you see right in here. 1, 2. 1, 2. Wait a minute. 1, 2, 3, 4, 5. There's someone missing here. Let's see what's going on. Yeah. Now here would be this and this. Those 2 that looks like they're skewing the curve in the wrong direction. Okay. Next. We talked to Carlo Gallardo. Right now, the next one is Angelica. Is Angelica there? No, Angelica is not there. Next is Princess.
Hello.
Hello, did you manage to download the spreadsheet, Princess?
Yeah, I did.
Okay, did you plot the first graph?
Yeah, I did plot the first graph.
What was the slope that you got for the first graph?
So my slope was 0.9845.
845. Okay, that's very good. Less than 2% difference, right?
Mhm.
If you log this value here in the last table, you're gonna get less than 1.5% difference, more or less. Did you plot the second graph?
I did.
Okay, what did you get for the second graph for the slope?
I got 0.9976.
9976, yeah, even better, right? And let me see, I think there is something else that we have to do. Let me check that I'm skipping here. Number. Let's go plot. Yeah, okay, yeah, you gotta look at the intercept as well, okay? Not just the slope, but the intercept of the first problem as well. Okay, so let's see, I'm gonna log my slope. The slope for the first graph, right? First chart. The slope for the first chart is 0.8085. 0.8085. And then I gotta put the unit here. I'm getting, like I said, 19% difference, right? But there's nothing much I can do about. But then you gotta log the intercept as well. Look at your equation. The intercept that I'm getting is 0.0983. 0.0983. 0.0983. Okay? And it's pretty good. It's less than 10%. And then I'm gonna do for the tangent as well, right? The second graph is this one here, 0.8382. 0.8382. Don't forget to log the units here at the top. Okay, so look at the intercept as well. Let me add that to the list that I didn't add before. Slope 1, percentage difference. Intercept 1, right? And then there will be a percentage, another percentage difference, another percent difference. So for everybody who has already plotted the graph, don't forget to log the slope, not just the slope, but also the intercept of the first graph. Let's go for Brandon Guerrero. Did you download the spreadsheet, Brandon?
Yeah,
Okay,
I'm
good.
still doing the graph.
I can't hear you.
I'm still doing the graph right now.
Okay, you're still working on the graph. Okay.
Yeah.
Okay, so let me put it, log it working. Next is Jenny Maldonado. Jenny Maldonado doesn't seem to be here. Next is Kimberly Morales.
Yes, I graphed both graphs
Okay.
and the intercepts.
Okay, so let's see. Graph 1 and graph 2. What is the slope 1? Or the slope
I
of
have 0.8554.
554? Okay. So the percentage difference is going to be around 14%. What's the intercept that you're getting?
That one was 0.0882.
882. Okay. And it's supposed to be 0.09. Okay, that's what this one is supposed to be. Okay, let me get this thing, which is very good too, right? And seems to be 7% more or less difference. Okay. And don't forget to, what about graph number 2? What's the slope of graph number 2? Did you get it, Kimberly?
Oh, sorry. Yes, it's 0.9915.
Okay, so very good too, right? Less than 1% difference. And so go ahead, log those values. And in the last table, format, number 4. Okay, percentage difference. And now we can talk to Montserrat. Is Montserrat there? Okay, both got, okay, so let's see. No problem with the download, right? You plotted graph number 1. Yeah, that's the slope, right, Montserrat? What about the intercept of graph number 1? 0.9915. Okay, you have the same numbers that Kimberly has because you are using the same, you are in the same group, right? Yeah, group number 9. 0882. Okay. 0.0882. Okay, good. So it's yeah, it's a very small percentage difference, should be around 3 or 4% difference. Okay, thank you, Montserrat, and keep on doing the other stuff. Let's go for Nicholas. Nicholas is not here. Next, Jason.
Yes.
Yeah, did you download the spreadsheet, Jason?
Yes, I was able to download it.
Did you plot graph number 1?
Yes.
Okay, what's the slope that you got?
Right now I'm trying to log on, but I think my slope was 0.26 something.
0 point what?
26?
You mean 6.6? Is that what you said?
I think so, yes.
Okay, let me see. That number seems awfully too high. Let's see which group you are. You're group number 10. Let's see if I get the same result. Lab number 3. Okay, so M3 average square, M2 square, insert. Okay, well, let's see, add trend line. No, I do not get that 0.66. I'm getting 0.93, 0.9398. Okay, maybe you plotted the wrong graph there. Okay, it's
Okay.
is this, this column and this column here. Okay, and don't forget, so check what, if you did anything wrong there, if you did anything incorrect there.
Okay.
Okay, and I'll get back to you in the other run. Okay.
Okay, thank you so much.
Welcome. Armand. Armand is not here. Juan Torres Arellano. Did you download their spreadsheet, Juan? Yes, good. Did you plot graph number 1? The slope of the first one is 9893, 0.9893. What is the intercept? This percentage difference is a little bit more than 1%, right? 0.9893. What's the intercept value that you are getting? Well, you gotta look at the equation, right? You gotta look at the equation. Here you go. Here's the equation, right? This value here is the slope. This one here is the slope, and this one here is the intercept. Okay? So all you gotta do is to read this value here for me in your regression equation. I guess you can see my 0.9, okay, 0.0917. That's good. That's a good value. And 0.0917. 0.0917. Yeah, that's what should be less than 1% difference. That's a good value. What about graph 2? Did you manage to plot graph 2? The second, okay. Yes, the second 0.96. Yeah, 3.2. Okay, 3 to 4% difference. That's good. Okay, keep on doing the other stuff, right? And let's go to Cecilia.
Hi.
Hello. Okay.
So I think I need help with my chart because I got a 96% difference.
Okay, your group number
12.
12, right? So let's go, let's see what's happening here.
So I think I did it right. I mean, I plotted well, I just followed it says to plot the M2 squared in the x-axis and the M2 3 average in the y-axis.
You said you're getting 96% difference. Is that what you're getting?
Yes.
Wow.
I don't know what I did wrong.
Okay, let's see what's going on. You gotta plot. Here you go. This column, right? And this other column.
Yeah.
Insert chart. Here you go. Yeah, the points are all over the place, right? But I don't think it's a 96% difference. Let's see. Add trend line, display equation chart. Yeah, I'm not getting 90%. I'm getting only 12% difference. Okay?
Okay, let me try to replot them and see if maybe
Yeah,
I
try to
plotted them wrong.
replot. Maybe you did something wrong there, right? 12% difference only. So I'll get back to you. Let me go to the next. I'm gonna write down that you're getting 96% difference, okay? So I know. I'm not there possible. No, I don't think that's the reason. Okay. Download. Next is Jacob. Jacob is there. No. I don't see Jacob here. Evelyn Ayala. Evelyn, no. Evelyn is not here. Isabella Cisnero. I don't see Isabella here. Trin. Are you there, Trin?
Yeah, but I was having a hard time the actual file.
Actual file. Okay, you gotta download. Do you have the link to your group folder?
No, because last time you sent it via email, and that's how I was able to access the lab.
Yeah, and you should still have this email, right? If you have this email, you can copy the link that I sent to you and use it again. It's the same link.
Okay.
Doesn't change. Doesn't change throughout the
Okay.
semester. The link of your group
Gotcha.
folder. Make sure you store it in a safe place. Okay, so it's working on the download. What about Elizabeth? Are you there, Elizabeth? I don't see Elizabeth here. Okay. Okay, so I'm gonna give you a little bit more of time. We have plenty of time today, huh? 12:20.
Professor,
Yeah.
sorry. Can you look at my chart? I think I'm doing something wrong. Sorry, group 4.
Okay, group 4. Let's go get that. Copies. Group number 4 right in here. Okay, and here you go. Which chart are you talking about? First chart or the second one?
The first chart.
Okay.
Sorry, do I need to get out of it? I don't know.
Okay, so here we go. Okay, that's okay. I'm gonna plot the first one. Okay, that's the second one. The first one is this one and this one. Okay.
Mm-hmm. Yeah.
Insert, chart, scatter. Okay, did you get something like that?
Yes, that's what mine looks like.
Yeah, we have an outlier here. Okay, so let's see. Add trend line, display equation chart, display R square value. Yeah, I'm getting a good slope here, and I'm getting a good intercept too. It's a little bit on the low side, but it's because of this outlier. Okay, it's a 10% difference. I'm getting 0.9097 for the slope, which was supposed to be 1. And I'm getting 0.0887 for the intercept, which was supposed to be 0.09. Okay, what are you getting for the slope and the intercept?
Okay. No, I got exactly what you got. Good. Okay.
You got the same value?
Yeah, I did.
Okay, so there's nothing wrong, right?
Okay, thank you.
Okay.
Professor, I was able to fix mine, so now I have the correct percentage difference.
Okay, who is that?
Cecilia?
Cecilia, okay. Let's go. You're getting like what 96% difference, right? Okay. What are you getting for your slope?
The slope is 1.1210.
1.12, just like I got. Okay, good. Did you find out what was the problem? Why we were getting that strange result?
Yeah, I think I plotted.
You plotted incorrectly?
I plotted them a different way than you, but I was still trying to do the y-axis. I mean, I had the same data in the same places, but for some reason it just plotted differently. So I just
Okay.
did the same method that you did.
Okay. What's the intercept that you're getting there?
The intercept is 0.105.
0 point?
Yeah, 105.
I can't. I don't understand.
So 0.105.
No, 0.105. Now there's something wrong here. The intercept. That's the number that you're getting for the intercept, right? 0.105, right?
Yeah.
No, there's something wrong here. Your group number, let's see,
12.
12. And I plotted, okay, must be this one here. Okay, what I'm getting for the, oh yeah, that's right. 0.01, okay, the same thing. Yeah, there's nothing wrong there. Okay.
No, okay.
Yeah, there's nothing wrong. And what's the percentage difference we get for this one? Let's see.
16,783.
Okay, that's not bad. Okay, that's not bad. And did you plot the second graph as well?
Yes.
Okay, so let's
So
see.
that one, the slope, I have 0.9330.
0.933.
Uh-huh.
Okay, which is good. Good. 6 to 7% difference. Okay. And okay, so if you plot all those graphs, you know what you have to do is log in them, log them in the last table, right? Look at the percentage difference. Once you're done doing that, look at the units, fill up the units, work on the sig figs. And let's go there today. Fill up the table for the regression equation and R square. Regard insert, where is insert? Okay. R square and regression equation. And the last one and the most difficult one is the CL, right? So I'll give you some more time to continue working on that, and then I'll call you soon. $20 more minutes to go. Let's see, okay, let me go back to Trin, right? Trin, did you manage to download your spreadsheet?
Yes, sir.
Okay. Did you plot the first graph already?
I have not. I'm not currently able to do that right now.
Okay, do you know how to do that?
Yeah.
Okay. Okay, so let's see. Brandon was working on the graph, right? Let's see, Brandon.
Yeah, I did both already.
Oh, you already did both. Okay, so let's go here. What's the slope that you got for the first graph?
0.1037.
0.1037, is that right?
Yeah, 1037.
Yeah, there's something wrong. One no seems too low. See if I type it correctly, the value.
Yeah.
I'm asking the slope, not the intercept, okay?
Oh, is that the R squared? Am I?
No, it's not the R square. It's let's see. It's
No.
here you go.
It's
When
just
you
numbers to
plot
me.
the graph, you get this equation. Here you go. Let me zoom in. Here you go. When you plot the graph, you get an equation. It's not your graph. It's a different one. Okay. You get this
Yeah.
equation here. The slope is this value that's multiplied.
Oh, I had the wrong one then. It's 0.0365. 0.0365.
But is that the slope or the intercept?
It's the first number.
Okay, so tell me again, what's the value?
0.0365.
Yeah, it's also too small. Too small. There's something wrong there. That's not the right number. Okay. Let me get let's see what's going on here. Your group number 8, right?
Yeah.
Let's see, group number 8. If I have 8 here. Group number 8. Okay, and that's the second graph. Okay, the first graph is this one. M3 average square, highlighted that.
Yeah.
And then press control and highlight M2 square. Did you do that as well?
I did it a different way, so I wasn't sure because I'm like on a MacBook and everything.
Oh, you're in a Mac. In a Mac, you have to hold the command key. Okay. Highlight this one, hold the
Here, I'll
command
just redo
key,
it real quick.
and you highlight this one here.
Yeah.
And when you plot, you get this plot here, points all over the place, right?
Yeah.
So
Hang on. It's giving me two different things.
that's what the equation I'm getting.
Yeah, I think I did it wrong because I'm getting like two different things. So
Okay, so check what you're doing. So that's the equation you're supposed to get at the top. R squared is this value. Okay, so I'll get back to you soon. Let's see if there's anybody else that I have to talk to. Three is still working, right? Now let's see. Delisha, are you there? Did you plot your graph, Delisha?
Yeah, I'm here. I'm still doing it right now. But yes, I think I figured it out.
Okay. The other students, Arwa, are you there? Did you plot your graph, Arwa?
Yeah, I'm here. I'm still figuring it out.
Professor, can you look at, sorry, I think I have a delay on my phone.
Huh?
Can you look at my graph for a second? I think I did it, but I'm not entirely sure.
Okay, your Delisha, right? What's your group number?
4?
4. Okay, so let me see here. I'm gonna display what I have here in my computer, and then you compare. Okay, what you have in
Okay.
there. Okay, this is the graph I'm getting for group number 4, and that's the regression equation. Let me make it larger so you can all see. Can you see it? Oops. Oh gosh. Let's try it again. Okay, good. That's the regression equation I'm getting. A slope of 0.9097, intercept of 0.0887, and these are squares. Is that what you are getting?
Yes, that's what I'm getting. I think it just shows up differently on mine because I'm not on a Mac, but yes, that's, I guess, what I'm getting.
Uh-huh. Okay, but if the numbers are the same, then it looks like it's, so log, right? Log those values right in here in the last table, right? The slope values. Let's see. Units, values. Okay. Value for the slope, value for the percentage difference, value for the intercept. Okay.
Okay. Thank you.
Welcome. 12:34. We have what, another 15 minutes to go, right? Let's see, someone else. So Delisha managed to plot. Did you plot the second graph too, Delisha?
Yeah, I believe I did.
Okay. Okay, so check, when you log in the slope and the intercept in the last table, you will have an idea whether you got a value close to what you're supposed to get, right? Let's see. Anybody else that I have to talk to? Trin, are you still working the graph, Trin, the first graph? Okay, I cannot hear from Trin. Let's see, is Edith there? Did you plot graph number 1, Edith?
Yeah, I did.
Okay, good. What's the slope you're getting?
I got 1.0899.
Okay, good. That's 9% difference. That's a good result. What about the intercept?
I got 0.3238.
0.3.
238.
Okay, there's something wrong with this number. Okay, so your group number 1. Let's see. Don't forget, I'm asking the intercept, right? In the equation. Group number 1. Let me get the table of the spreadsheet of group number 1. Group number 1. Let's see. Okay, here you go. That's the graph, right? Here you go. That's the regression equation. The regression equation that I'm getting. Oh, boy, again. I keep on doing that. Has been some time that my computer. Okay, here you go. Did you get this regression equation here?
No, mine is different. I got a different result.
Yeah, so let's see. Let's
Can I
walk step by
can I
step,
share
right?
my screen?
What's that?
Am I able to share my screen to?
Oh yeah. Let me. Let's see. Let me go to the controls here. And I have to stop sharing as well, right? Go ahead, share your screen. Okay. Your group 01. Okay, that's the second graph. Okay, that's not the first graph. That's the second graph. You switch it. Okay.
Oh.
Yeah, that's right. Oh, wait a
Okay.
minute. Wait a minute. Go a little bit up. Go a little bit up. Click the graph number 1. Oh no, you plotted the wrong thing. You plotted the wrong thing. Okay. Okay. So you see the bluish thing. It's not M3 average. You are supposed to highlight the M3 average is square, the one next to the right.
Okay.
That's the mistake. So
Got it.
click this box and drag it to the right. Let's see if we can do that. No. Click it. Wait a minute. Click again the graph. Click the graph again. Okay. Now I want you to click on the edge. Yeah, and try to drag to the right. Okay. Now the other edge. Yeah. Drag. Yeah. Good. Now we got the right thing. Okay. Now you got the right thing. Okay. Now I should have the right result there. Okay.
And then
9893, right? 9632. Let me write that down here in my 9 delay. You are Edith, right? Slope. Read the slope again. 9893, right? 9893.
yes.
And the intercept is
0.0917.
0917. Okay, good. So, and what about plot graph number 2? You did graph number 2. What's the slope you're getting?
I got 0.9632.
Okay, good. Which is a good number as well. Okay. Okay, what about, thank you, Edith. Now work on the rest of the stuff, right? We have 10 more minutes to go. What about Eric? Eric, did you plot your graph number 1? Oh, I have to share my screen now. Let's see. Share. Here you go. I'm sharing my screen now. And let's see if Eric is there. Looks like Eric left. Okay. And I put it here. Anybody else? Let's see. Arwa? I'm back to you, Arwa. Did you plot your graphs, graph 1 and graph 2?
Not yet.
No? Do you have any problem? Do you need any help?
Yeah, the thing is that I'm using a Chromebook, so the keys are not the same as there for you.
Okay.
So I'm not sure.
You're missing what? You said missing?
I said I'm using a Chromebook.
Oh, you have a Chromebook. Okay. Yeah. Okay, the Chrome is different. Yeah, indeed. See if you can get a laptop or get a desktop somewhere, because the Chrome, yeah, some people manage to work with the Chrome, other people don't, so see if you can get access to either a laptop or a desktop during the labs, okay?
Okay.
Let me write that down here, Chromebook. And I'm not familiar with the Chromebook, but I believe that you can install Excel there, right? In the Chromebook, I believe you can.
Yeah.
Okay. Hello, Trian. I don't want to put pressure on you, but let's see. Trian left. Okay. Trian left. 8 more minutes to go. Let's see here. This one goes here. plot. And okay. Okay, I gotta write down. Delisha, are you there?
Yeah, I'm here.
Okay, can you tell me the slope of graph number 1?
Oh, I just closed out. I'm so sorry.
Okay. Okay, so but you plot both graphs, right? From what I see here, I just didn't write down the
Yes,
slopes. Okay.
I plotted both.
Okay, good. So let's see. Someone has a message here. Who's that? Okay, Ben Bendoy. Okay. Did you get the CL as well? Okay, good. Okay, if you finish, you can go. If you haven't finished yet and need some help, you can hang around and let me know. We have 7 more minutes to go. Okay. And let's see someone else here. Let's not forget, next time we meet is going to be an exam, right? Monday is going to be a holiday. And the exam is going to be on a Wednesday, the Wednesday next week.
So,
Professor?
Yeah.
Sorry, you go first.
Okay, thank you. So we don't have class on Monday?
That's right. Let's make sure you don't have class on Monday. I want to make sure so I don't make a mistake here, right? Here we go. We go to admissions, welcome center. Let's see. Layout, reach, ordering, transcript, where it must be here. Calendar and schedules, right? Schedules and catalogs. Let's take a look here. That is not the spring 26. We want the fall 25. That's the one right in here. And that's schedule of the classes. Let's see if I can zoom in. Yeah, I'm zooming in little by little. And we are supposed to have a place here, a page, internet registration, last day, holidays. Okay, November 11 is Veterans Day, right? Wait a minute here, Monday. Oh yeah, that's November 11. Why does it say Monday? It's not a Monday, it's a Tuesday. Huh, do you see that? He said it's a Monday. It's not a Monday, it's a Tuesday for my calendar. Oh my goodness, what we're gonna do here? What about the other courses that you are taking? Are they taking the day off on Monday?
Mine's Tuesday. That's the day off
Yeah.
because I have to go in person. So they said
Yes.
Tuesday.
See what the catalog did? It made a mistake. It printed Monday where it was supposed to be Tuesday. Oh gosh, what are we going to do here? Okay, that's well, what a let us meet anyway, because otherwise you're going to be too behind. Okay, I will change the schedule because this date here is supposed to be a Tuesday. Keep watching my emails. Okay, I'm going to ask around the college. I'm going to ask the dean. Okay, on my chair and see what's going on, and watch for my emails, and then I'll let you know whether we're going to have a meeting or not. Okay. So it's really an odd situation in which they made a mistake, right? They said November 11th. Let's see. Let's take a look at the internet. Veterans Day. Veterans Day. Let's see. 2025. It's a Tuesday, yeah. It's a Tuesday, November 11th. Yeah. At this point in time, there's so many. There's a mistake there, right? But okay, watch for my email, and I'll let you know whether we are gonna have a class meeting or not. Okay? You have Tuesday off, right, Jason? Okay, thank you. But not Monday, right? Monday they have class, right, Jason? Okay. Yeah, so most likely we're gonna have a class on Monday. I want to have a class on Monday so I can move ahead with the material. Okay. And it's really surprising that they made this mistake in the course catalog. It's not a Monday, it's supposed to be a Tuesday. But I'll let you know before Monday. Okay, it's 2 minutes to go. Do you have any questions?
Professor, I actually have a question in regards of lab number 2.
Yeah, what's that?
For the confidence level, mine R square is great, like it's a great value, so it's not within the chart.
Okay, so what's the value of the R square?
0.9997.
Okay, 9997. Okay, good. Okay, I think I know what's the problem. Let's take a look at the spreadsheet, right? At the spreadsheet, no, at the table, CL table. Let's see if I get here. Petition, confidence level, right in here. And I'm going to zoom in. How many data points we have? We have
10.
10, right? Okay, so you gotta look at this row here, right? So your 9997 falls outside in this region, right? Outside the table, right? Okay, so how do you handle that? There is a way to handle this one, okay? Definitely, because your R square falls outside this table to the right, it means that your CL is going to be greater than this value. Make sense?
Yes.
That's going to be the lower bound, greater than this value. But then what's going to be the other value? What's going to be the upper bound? Okay, what's going to be the upper bound? You got to remember what are the values of the confidence level, right? Here you're seeing only the value between 0.95 and 1 minus 10 to minus 7, right? But further down, further to the right of the table, what's going to be the last value of the confidence level here? What's going to be? What's that?
100%?
Yeah, 100%. Going to be the number 1, which is 100%. And what about to the left of the table? What's going to be the value at the extreme left of this table?
I don't know.
Well, it can only go from 0% to 100%. Okay.
Oh yes.
So in the extreme left here, that's not in my table, is 0%. In the extreme right, is going to be the number 1 or 100%. Okay. So you log for the lower bound, you log this value. For the upper bound, you log the number 1. Make sense?
Can you repeat that again?
For the lower bound of the CL, you log this value here, 1 minus 10 to minus 7.
Yeah.
And for the upper bound, the maximum value, you log the number 1.
Okay.
Okay.
All right. Thank you.
Don't log 100, right? Don't log 100. Log 1.
Okay. All right. Thank you.
Okay. Okay. So we're past the time. Is 12:52 already, and hopefully I see you on Monday. And just watch for my email and any message that I'm gonna send. Okay. I'll see you on Monday. Bye bye.
Thank you.
Professor.
But